I decided to circle back to a graph chart derivative problem. I know it's a graph chart derivative problem. It's specifically a double chart problem because here in the beginning it says the different derivatives or values at points for the function f, and then it has function g and the same kind of thing. There happens to be no graph, and maybe there's a derivative later on that I have to find or something. But I would definitely recommend pausing, trying the problem before I do it, and then looking through, watching the video, and seeing if you did it the same way. Okay? This is problem 5 from year 2014, so it is no calculator. All right? The twice differentiable function f and g are defined for all real numbers. Values of f, f prime, g, and g prime for various values of x are given in the table above. So basically what I already knew. Find the x coordinate for each relative minimum of f on the interval x is -2 to 3. Justify your answers. So I'm looking for minimums in this case. Minimums, and I'm only looking at x. So f of x, or f prime of x. My first question would be, when do minimums occur? And that would be when the derivative is equal to 0. So let's see if this derivative is ever equal to 0. It's equal to 0 there, and the derivative is equal to 0 here. Okay. Minimums specifically occur when the derivative goes from, we want for minimums, a relative minimum, it needs to go from negative to positive. Okay. So in this one, it goes from negative to 0 to negative, so that's not a maximum or a minimum. That would be like an inflection point possibly. So right here would be negative to 0 to positive, and so that spells out that it's going to be a minimum. Okay, so the x value is 1. Find the x coordinate. So x equals 1, box that up, and then you have to give your reasoning. And I'm going to say because f prime of 1 is equal to 0, and the value goes from negative to positive. I'm also going to give like a little negative, 0, positive, negative, 0, positive kind of graph, like it's a minimum. Okay? All right, next one. So explain why there must be a value of c, so intermediate value theorem, mean value theorem most likely, from -1 to +1. So from that value right here to that value right there. That's nice that they're narrowing it down for us, such that the second derivative of some value is equal to 0. So we're not given the second derivative, so we're obviously going to have to take the derivative of that, which means we would be talking about the mean value theorem. So, because we're talking about slopes from 0 to 0, if you're going from a slope of 0, or the value of 0 here, to another value of 0, then there has to be a 0 slope in between, right? That specifically is the mean value theorem. So I'm going to say f prime of x is differentiable. Therefore, f prime of x is differentiable. Therefore, the mean value theorem tells me that if this slope right here, which is 0 minus 0 over the x values, so -1 minus +1 equals 0, then on the interval c value exists, and I'm going to say f double prime of c equals 0. Since that average slope was 0, the instantaneous slope can be 0 also. There will be an x or a c value with that same slope. Okay? And part C, the function h, so they are introducing a new problem. That's why it is, graph, chart, and derivative problem. So the function h is defined by h of x equals ln f of x. So this new thing that they just introduced, they want me to probably take a derivative and then plug in 3. And I'm going to use the chart to plug in 3. Show your computations to lead to your answer. So the derivative of h is h prime, and that's equal to, and the derivative of ln of something is 1 over that something, right? And we also have a chain rule on it, so the derivative of f is going to be f prime of x. Okay, and now we just have to plug in 3 to both of those guys. And really by plug in 3, I just mean find it on the chart. So I still have a fraction, and f of 3 is right here. F of x is 7. And 3f prime is going to be 0.5. So you could leave the answer like that, I suppose, or you could double the top and get 1 and double the bottom and you get 14, just to clean it up a little bit. We are in AP Calculus, so it seems reasonable. Okay. And last one. Last one's a little goofy because they're setting up an integral, and integrating something like this looks kind of scary. But it says evaluate from 3 to -2 f prime of g of x times g prime of x, which looks like a chain rule already occurred to me, right? So I feel like I could guess what the antiderivative of that would be, or I could say u equals, I think, g of x, and so that means du over dx equals g prime of x, and I would use that, move that dx over to the other side, and it looks like dx g prime of x, that thing would be f prime of u, so it would clean up real nicely. But I think, like I said, I could just guess what the antiderivative would be, and the antiderivative of f prime would be just f with a g inside, right? If I took the derivative of this, it would be f prime with g of x, and then the derivative on that would be another g prime. And I still have to evaluate it from 3 to -2. Okay? So it's going to be kind of like a leapfrog, like you plug into one and then into the other. I'll write it down though. It's going to be f of g of 3, right? And then take away f of g of -2. Okay? So first I'm plugging in 3 to g, and then I'm going to take that new answer and plug it into f. So 3 gets plugged into g, which is 1, and then you take that new value of 1 and plug it into f. So I end up getting 2. So this part is 2. Right? And then we still have minus, and like I said, I'm going to take that -2 right there and I'm going to plug it into g, and then I'm going to take that new answer, which is really the value right here, right? And I'm going to plug it into f. So -2 right there gets plugged into g, which is -1. Okay, and now that -1 gets plugged into f, -1 gets plugged into f, and that's going to be 8. 8. It's kind of like that whole thing right there was -1. Right, so it's f of -1 now, so ended up getting 8. And final answer is -6. Box up your answer. Like I said, I definitely would recommend pausing along the way. Hopefully you did that to try to challenge yourself a little bit more. If you're just watching the video and just trying it without pausing, you're really kind of giving yourself a disservice. And sorry if you heard little kids in the background. My kids are a little crazy, like you guys know. They were in class every once in a while. They're up on the hill, they're acting a fool. I need to go yell at them probably.